Today we're going to move on into radian and degree measure. Yesterday we covered coterminal angles, which is a pretty easy concept. But this idea of a radian in trigonometry is one that's probably a little bit new to you. And to understand it, we have to consider a circle. It was actually the ancient Egyptians that discovered, we just came through Pi Day, it was the ancient Egyptians that discovered the fact that if I measure the circumference of a circle, okay, if I measure the circumference of a circle, which remember is just the distance around, if I measure the circumference of a circle and compare it to the diameter, if I take the circumference and divide it by the diameter, I will always get pi. Okay, and it was the ancient Egyptians that discovered that ratio. All right, every circle known to man. It's actually was one of the most amazing discoveries in all of mathematics. Every circle, I don't care what it is, if you measure it exactly and divide it by the exact measurement of the diameter, it will always equal pi. Okay? So, now, let's kind of take this a little bit farther though. If I solve this thing for circumference, which would be, remember, multiplying both sides by d. If I multiply both sides by d, and I get that circumference equals pi times diameter. All right? Well, what's another way I can write diameter? Isn't a diameter two radiuses, right? So I could write this as the circumference is equal to pi times 2r. All right? And if the radius is 1, if the radius equals 1, what would the circumference be? Well, let's put a 1 in for the radius. I would have pi times 2 times 1, so the circumference would be 2 pi. Or another way that we could say 2 pi, the numerical value, 6.28. Okay? So when we talk about a radian measure of an angle, okay, yesterday you heard me refer to 2 pi. Well, 2 pi is the same thing as 360 degrees. But the difference is, instead of looking at degree measure, we're looking at arc length. Okay, the arc length that is intercepted by a certain angle. Okay? So when we talk about radian measure, the radian measure of an angle is describing the arc length that the angle intercepts on a circle, and specifically what we would call a unit circle. When we say unit circle, we're talking about one that has a radius of 1. I know you're used to using the word units to describe like centimeters or miles or kilograms or whatever, but another synonym for unit is 1. Okay? So if we talk about a unit circle, and we talk about the arc length, if we go all the way around, there are 2 pi radians measuring the arc length all the way around. We just explained how that works. All right? So, let's think through this now. Didn't I say that 2 pi is the same thing as 360? Right? So what do you think 1 pi is? If 2 pi is 360, isn't just pi half of that? Wouldn't that be 180? Right? So in other words, we can label this thing. I'm going to draw a new circle here before this one gets confusing. And let's just start with this statement. Radian measures an angle by arc length instead of by the increments of a degree. You were used to using a protractor, all right? And if you think of the way a protractor works, it's almost like the second hand on a clock, okay? Well, this is measuring arc length. So let's draw a new circle, a new unit circle. And let's kind of break this down a little bit. I told you that 2 pi equals 360 degrees. And then we just followed that up by saying that pi is 180 degrees, which makes sense. So remember yesterday when we started talking about coterminal angles, we said we always start here. So if this is 0 radians or 0 degrees, then if I swing this way, then by the time I get over here, this would be pi radians. All right, which is the same thing as 180. All right, and I think we can see that's a 180 degree angle. So this up here, this 90 degree angle, okay, we know right here is 90. Well, isn't 90 half of 180? So this would be half of pi, or we usually call it pi halves. Okay, so now we can add something to our list here. Pi halves is 90. All right. So what's half of 90? 45. Okay, so now we need one for 45 degrees, which is going to be right here. Well, what's half of a half? Isn't it a fourth? So this would be pi fourths. So pi fourths is the same thing as 45 degrees. Well, let's keep going. How about 30 degrees? 30 degrees. What would I multiply 30 by to get 180? 6. So isn't this a sixth of pi? So we would call this pi sixth. Okay, so if I look at a 30 degree angle, it's right in here someplace, and it is pi over 6. What do you think 60 degrees would be? What would you multiply 60 by to get 180? 3. So it would be pi thirds. So if I look at a 60 degree angle, which would be right in here someplace, it would be pi thirds. Okay? Now, here's the nice thing. We can use this to our advantage as we go all the way around the circle. All right? Let's start with pi halves. Pi halves, isn't 2 pi halves the same thing as pi? Right? So 1 pi halves, 2 pi halves, that would make this one 3 pi halves down here, which is the same thing as 270. Okay? And see, I can count up with any of these that way. Let's look at the pi fourths. Pi fourths is the same thing as 45. So 2 pi fourths would put me right here at pi halves. 3 pi fourths would put me right here at 135 degrees. 4 pi fourths would put me at pi. 5 pi fourths would put me down here at, 180 plus 45, 200, this would be like 225 degrees. And I can keep going all the way around the circle. 5 pi fourths, this would be 6 pi fourths, and here would be 7 pi fourths, and if we keep counting, I get right back to where I started, and we said 8 pi fourths. Well, that's the same thing as 2 pi. Okay? Remember what we're talking about. We're talking about the length of the arc that is intercepted by this angle. All right? So, what I want to show you now is a little trick for remembering, trying to keep some of this straight. Here's a little trick. Okay, no extra charge for this. This is all part of getting a free and appropriate public education. Let's say if I know if pi sixth is 30 degrees, then 5 pi sixth is 5 times 30. Right? So it would be 150. Do you see how I did that? If I know this statement right here, that pi sixth is 30, then when I have 5 pi sixth, all I have to do is multiply the 5 times the 30. Right? So what would, for example, what would 7 pi sixth be equal to in degrees? Wouldn't it be 7 times 30? Which is 210. Okay? And so, you can use that little, that's a nice little trick, especially for the ones that have a denominator of 6. You can also do it with the ones that have a denominator of 4. I could also say, but it's a little bit harder to do that in your head. If I know that pi fourths is, 45 degrees, then 3 pi fourths is 3 times 45. That's a little bit harder to do in your head, but I think most of you could probably still do it and see if that's 135. Couldn't you also do it with pi thirds? What's pi thirds? Pi thirds is 60, right? So 4 pi thirds would be equal to 4 times 60, which is 240 degrees. Okay? That's a nice little trick for some of these common values, like 30, like 45, like 60. Unfortunately, they're not all nice and common. So we need to talk about how we convert the official way that we convert radians to degrees and degrees to radians. Well, first, how about radians to degrees? One good way to remember this is the same way you've learned to do conversions in science. You want to get the thing you're wanting to go away to cancel. All right? So here's what I'm saying. If I know that pi is the same thing as 180 degrees, right? You remember in your unit conversions in science, don't you use a form of 1, right? And I use the fact that pi over 180 is the same thing as 180 over pi. Okay, they're both referring to the same measurement. Okay? Now you might, if you plug that into a calculator, you wouldn't get the same thing, but you have to know that these are equivalent. So what you do is, if I'm going from radians to degrees, I'm wanting, let's say that I have a radian measure, for example. Let's say that my angle is 7 pi sixths. Okay? And I want to change that to degrees. Well, which one of these two over here has the pi in the bottom? The one on the right. I'm going to use this one because when I multiply by 180 over pi, the pi's will cancel. Because I'm trying to get the pi's away and change it to all degrees. All right? And now we can do our basic, we really don't even need a calculator. I can just finish factoring this. 6 divided by 6 is 1, and 180 divided by 6 is 30. 7 times 30 is 210 degrees. So in other words, if I'm going from radians to degrees, I multiply by 180 over pi. Okay? Now you might be saying, well, I thought you just showed us a trick for ones that have a denominator of 6. I did, but they don't all have a denominator of 6. Okay? They might be something like this. Another example. They might be 5 pi twelfths. Okay? Not quite as convenient. So, again, all you have to do is multiply by 180 over pi. Right? Your pi's cancel. 12 will go into 180 evenly, by the way. Anybody know how many times? It's 15. 12 divided by 12 is 1. 180 divided by 12 is 15. 5 times 15 is 75 degrees. Okay? So, you know, that always works. Hey, what if they give you a strange radian measure like this? What if they say 2.7 radians? What if there isn't a pi? Well, that's possible. Okay, you don't always have to have a pi for it to be in radians. They could just tell you it's 2.7 radians. Well, if I want to change that to degrees, I do the same thing. I multiply 2.7 times 180 over pi, and what you're going to do is you're going to get a decimal answer with your calculator. Okay, there's no pi to cancel. I mean, I could put this over 1, but there's no pi to cancel, so you just do it on your calculator. All right, 2.7 times 180 divided by pi, 2.7 times 180 is that, and then you divide that by pi, and there it is in degrees, 154.7 degrees. All right? So sometimes you just do it on the calculator. All right? Now, by the same token, if I go the other way, if I'm going from degrees to radians, I want the degrees to cancel, so you would multiply by pi over 180 instead of by 180 over pi. So for example, let's say that I had 120 degrees and I wanted to change that to radians. I would multiply it by pi over 180. I'd put the 120 over 1 and do my factoring. 60 will go into both of those. 120 divided by 60 is 2. 180 divided by 60 is 3. Multiply across, and you get 2 pi thirds. Okay? Now, yesterday, and we may or may not be able to finish this all the way, we started talking about degrees, minutes, and seconds. degrees, minutes, seconds. Okay? And there's actually a feature on your graphing calculator that will do this for us. Okay? Let's say that I have 74 degrees, 8 minutes, 14 seconds. That actually is the measure of an angle. And remember that this thing right here is a minute, and this is the symbol for a second. Okay? And on the graphing calculator, all we have to do is, let me just show this to you before we run out of time. Type in 74, and you go to second apps. Okay? So you look for your apps button, which is right here in the middle, and look at what number 1 is. It's a degree. So you hit enter. Now it's 74 degrees. And we had 8 minutes, so I would hit 8, and I would go to second apps again, and look at number 2. It's my minutes symbol. Okay? And we had 14 seconds. I don't know why the TI-84 people did this, but the seconds is in a different place. The seconds, you press alpha and plus, and it automatically puts it in. I don't know why they put it in a different place, but that's where it is. Then you hit enter, and look what it's done. It has converted it into the decimal form of that angle. Okay? And what if you're given the angle in decimal form and you want to go back to degrees, minutes, seconds? Okay? Well, what you do is you type in the decimal form. Let's say my angle is 34.817. And I wanted to change that to degrees, minutes, seconds. Well, then I press second, apps, and I select number 4 for DMS, degrees, minutes, seconds. If you hit that and then hit enter, it automatically changes it into degrees, minutes, seconds. And we're going to stop there for today.